All right. Good morning, everyone. We're a few minutes after 11:30, so we'll get started. I wanted to thank everybody for taking the time to get on this morning. My name's Sean Huber. I'm one of the automation systems group managers here at Rumsey Electric. I want to thank you for joining us for our ongoing webinar series being hosted generally by Rumsey specialists. However, in this case, we do have a guest speaker. So with that, I would like to turn this over to Jerome from Gates, who's been in the power transmission business for a long time, specifically around belting and working for Gates. As Rumsey, we've had Gates as one of our main power transmission lines for a number of years at this point, and I believe everybody on the call should be aware of Gates as a company because they make a very, very good product and stand behind it with their name. So with that, I will turn it over to you, Jerome. And as I said, everybody feel free to mute yourself and ask questions as appropriate.
Okay. Just a little background on myself. Again, I'm Jerome Eversgerd with Gates. I'm a business development manager with the Gates Corporation. I've been in power transmission business on the industrial side for about 10 years. And before that, I had about 5 years on the automotive side with Gates. And just a little interesting tidbit, if you look at our logo there on the left, you'll see that the script writing sort of looks like the Ford logo. How that came about was really Charlie Gates and Henry Ford went to school together, and we were supplying Ford with leather belts at the time. And Charlie Gates' brother, John Gates, invented the V-belt in 1917. And that's really where all of this stuff had started. So today we're going to go over a little bit of preventive maintenance and safety, and then we'll talk a little bit about the product as well as we're going through this slide presentation. So some of the topics we'll discuss is safety, belt drive inspection, storage, installation, tension, alignment, troubleshooting, and failure analysis. We have this book here. It's a really good catalog. If you guys are interested, let me know, and I'll see if I can order you some of those, or we can get it to you online if you'd rather have it that way. So good safety practices for your power transmission drive installation. So you want to make sure you never put your fingers anywhere, and especially if something is moving, you want to make sure it's locked out and tagged out. We have one situation where, let's see if I have it on the next slide. No. So you want to lock it out, make sure everything's turned off. What I was going to say what happened was we thought everything was locked out and tagged out, and somebody came in and they cut the lock off and turned it on while we were actually looking at it. So everybody needs to be aware that if you're locked out and tagged out, they need to go look at what that drive is actually doing before they assume that somebody left the lock on and cut it off as well. When you make sure you have the proper safety equipment, I'm sure you're all aware of eye protection and ear protection, especially now. The right type of gloves and eye protection, hearing protection, eye protection, things like that. A lot more gloves are being used, to keep from passing germs and other things. You want to have a safe work environment. Again, like I was saying, you want to make sure you have all the safety policies understood. A lot of places you watch the video, you need to make sure what's going on with the different safety awarenesses at different places. It's more so even now with the COVID going on. Again, back to not putting your hands anywhere where something's moving, especially with HVAC. Sometimes you can be looking at it, if it's not secure, you can have what they call a windmilling effect where the fan will actually turn the opposite direction. So you don't want to have anything like that. This is called the Bird. You'll be getting a little brochure on that later. This is a belt installation rotation device. And what you do with this is once you seat the belts, then you can use these they're rare earth magnets to turn the shiv or the sprocket, and so that you can make sure that you're going to track that belt properly for once you unlock it and take the tags off and stuff like that, so that you can run it properly and make sure it's not going to jump off the shiv or anything. This is a really good device. So main purpose is so somebody doesn't grab the top span, say, and spin the drive to seat the belt. We've won a number of safety awards for this rare earth magnet device. I've sold a lot of those in all over the place. One in Delaware where the guy walked into the training session and he just did put his hand on top of that belt and he ripped his fingernail off of his finger because it got caught between the belt and the shiv. And so they bought that right on site. The best way to go with this one is don't go to your regular maintenance manager, but go to their safety person that they have. And it's almost 100% guaranteed sale with that device. Belt drive inspections. One of the main things with the belt drive is a lot of people are going to get upset and say, oh, these belts aren't working or something like that. But most of the time, the belt is telling you what's wrong with the drive. It's going to have a symptom. So you always want to, again, turn the power off, look at things like that. Do you guys know anybody have any questions about these shiv gauges? Does anybody know how to use the shiv gauges?
I think you ought to, Jerome,
Tell us,
just talk about that.
Basically what the shiv gauges is every shiv gauge is going to have three. As you can see in here, it looks like a three-sided star. There's going to be, and let's say in this example, we'll say there's 34, 36, and 38 degrees. And so with the shiv gauge, you want to read what the diameter is of the shiv. And so say in this example, it's below 12 inches, you'd use the 34 degrees. If it's between 12 and 16, you'd use the 36 degrees. And if it's over 16, you use the 38 degrees. So you want to make sure you're using the right gauge for the right size shiv. And all that was engineered back a long time ago as to what pitch that shiv needs to be so that the belt seats in there properly.
Jerome, what's a typical life of a shiv based on you dealing with belts consistently?
We used to always say that after the third belt change, you would want to check the shivs, but now almost all of your shivs are coming from China, and so the metal isn't as hard as it used to be. So what we're actually saying now is to check them after every time you change the belts because they're wearing out so fast. So it's a real simple thing with the gauges. We can get you some of those to start checking your belts, because a lot of times the shiv's going to be worn out. Your belts are going to be glazed on the side. What I mean by that is if you hold the belt up and it's really shiny, more than likely your belt is slipping a lot in the shiv. And with a V belt, you don't want it to ride at the bottom. And so as that shiv wears out, the belt is running lower and lower into the shiv and it's slipping. So a V belt is designed to slip. So a brand new V belt and a brand new shiv is going to run at about 95% efficiency from day one. And then over time, the belt is going to wear down on the sides from friction, and it's going to ride lower into the shiv. And then that's where you get the slippage. And we'll talk about that later on, where it's possible to save energy by switching from V belts to synchronous belts. So this one's still talking about excessive wear on your shivs, and that's what you want to check for.
Jerome, what are we, if you can go back, what are we looking for using the shiv gauge there? Like that.
Right here, you want anytime see how the point's going in between the shiv there? The sides of that red part down there should be touching the metal. If you have any daylight off to the left, like you would see there, say it was on both sides, still the shiv's worn out. It should be touching both sides of the metal on there, and it shouldn't touch at the bottom. So if it's worn, if you see any daylight in there, the shiv's starting to wear out, and then you're going to need to replace that shiv. Any other questions? So this one also, you can wear out a sprocket by having the belt too loose. It'll start over time. It'll run those teeth down so they wear off. Some of these are going to say that you should rub your hand across there. I don't recommend that because you can make those sprocket teeth so pointed that it'll actually cut you. And this will wear out the synchronous belt and reduce the tension. So the synchronous belt will look like if anybody that has kids, and they're like in first, second grade, and they draw a picture of going to the beach, it would look like the waves coming in, how they draw them like a little C how they for the water coming in. So on V belts, like this one saying for number 13, you want to go back and retension it. With synchronous belts, you don't have to do that. You just want to visually look at these and see if you can see that there's a difference. As you can see in the little sprocket to the right, the sprockets are always going to be slightly wider than the width of the belt. And so if it's wearing out, you can see it on the edge because the belt's going to find a home one side or the other, and it's going to ride and just wear those teeth out if it wasn't tensioned properly. If it was tensioned properly, sometimes you can get 10 years worth of running with that sprocket and say poly chain belt. We've had that in a number of cases. So some of the things we like to look at is look, listen, and feel. Take a look at it. Listen to the noise. A lot of the maintenance guys, they can just walk by a drive and they can tell by the way the sounds that there's something wrong with it. And then when you shut it down, lock it out and tag it out, take a look at the belt and see how it's wearing. If it's all excessively wearing on one side, you know it's not aligned properly, or if it's a synchronous belt, if some of the teeth are missing, or, you know, there's a number of things that can go wrong with it. But if you take a look at it before you take the belt off, you can see what the issue could be. And then when you put the new belt on, then you can correct that. So it depends on how critical it is to your situation. In some places, they might have to change a belt every 3 to 6 months because it's really critical. In other places where it's not that important, you can let it run for a long time. So some of the examples I give, like on this one, it talks about temperature extremes. If anybody likes to drink Yingling beer, they make the bottles up in Du Bois. I was up there and they have an exhaust fan it's like 300 degrees coming out of that kiln where they melt the basically sand in to make glass. And we converted that over to some of our ethylene type belts, which would be anything that has an X, a BX, a 5VX, like that. Instead of replacing the belt every 2 weeks, they were able to replace it every 6 months. Still not ideal, but it was a $40,000 cost savings just from them switching over to that one kind of belt. And this is going back to talking about your shivs, like I was saying before. You can look over on the edge and right there and see how it's worn out and stuff like that. Do a visual inspection. And this gets more detail into the worn shivs. This is a better example of where you can read the gauge there at 38 degrees. You can see up a little bit on the right where it says 34 degrees, and where his thumb's out, it'll say 36. So on that one that you can read, you can see the outside diameter, anything over 7 inches would be 38 degrees. And I forget what the numbers are on there, but you basically have the idea there. So you're looking at anything over 7 inches is 38 degrees, and below that would be the other two as an option. Replace your shivs and sprockets. You know, they can get rusted, especially if you have like a wet cooling tower or something like that. I don't recommend this picture down here with the sandpaper and stuff like that. If it's rusting up and stuff like that, you should just go ahead and replace it. It's you know, you're not going to get the same consistency all the way around there. It's just not, in my opinion, it's not the way to go about doing things. But you want to have a good clean belt. A lot of times that one on the top is coming from like a wet cooling tower or something like that in a real corrosive environment. Storage, that's one of the main things. How you store your belts is very important to help their life. As you can see here, you want to keep it below 85 degrees and below 70% humidity. It's okay to hang the V belts on the hook. We sell the poly chain in a box. You want to keep it in a box. Some of the examples in here, you can see every belt, no matter what size it is going to have a minimum bend radius, and you don't want to wad it all up and get below that bend radius, because then you end up breaking the cords away from whether it's rubber or from the plastic in the poly chain belt. So an example like this is destroying the belt right here. You can see off to the right and the left how the teeth are almost touching each other because it's bent together. And up there, you got it all twisted and wadded up. That belt isn't going to last very long at all because, again, when you're going around the motor, let's say the motor, you're going 1750, you're going to be bending that back and forth, 1750. That's no different than when we were kids and you'd bend a hanger and then break it and, burn your brother or your friend and show how hot it was. So that's where that belt's going to break, is on one of these ends right here. It's just going to break straight across. It'll look like somebody cut it. And then they'll wonder why that belt came apart after a short period of time. And again, like we have some of these belts, poly chain belts, running since 1998 on certain drives. That so for 22 years the belt's been on there, and then somebody will have a belt like this, and it won't last them 22 days. And we'll see that it's broke straight across, and every time it's because somebody did something like this, took it out of the box, watered it all up, and threw it on the shelf. This is another example. I didn't even know what this was when I first saw this picture, but it's a twin power grip belt. It's all wadded up in plastic shrink wrap, and this belt's supposed to be 8.5 feet long, and it's wadded up to about the size of a baseball glove. So again, the cords and all that are basically broke loose from the rubber. You go install this belt on the drive, and again, it's going to be going around, in this case, multiple sprockets, and it's not going to last long at all. Troubleshooting, we'll go over this real quick. Sources of drive problems. So poor drive design is a good one, but proper belt storage and defective drive components. Again, you have bad sprockets, bad shivs. Improper drive maintenance. They might have put it in and not had it aligned. Improper installation would be where somebody doesn't take the time to use the take-up bolts and bring the motor in a little bit so that they can get the belt over the shiv or the sprocket. They just take a large screwdriver and pry it over the edge. Well, then that breaks the cord loose from the rubber. And again, you're going back and forth over that driven motor, and it's going to break loose and look like like somebody cut it. Environmental factors, it could be extremely hot, like I talked about the Yingling bottles, or it could be a rubber belt and it's excessive water. Rubber's going to absorb water over time. That rubber's going to be like a sponge, and it's not going to ride in the shivs. So there's a lot of different external sources that could cause issues. Basic techniques for troubleshooting drives. You got to look, listen, and feel again. You want to use the right tools. Maintenance staff, if they're trained, sort of like what we're doing here. We have other PowerPoints and stuff we can go in to help train the people at whatever location you guys end up going to on proper installation. If the right size motor, the right size shivs are there, you might have too small of a shiv for the motor that you have. And then again, a belt always has a minimum size that it wants to go around on a pulley. And some of the other things you want to look at is this a recurring event? Is the same issue always happening with this drive? Then that's when you can call us. We can come in and take a look at it. See if it's a maintenance issue. Again, is the guy always prying the belt on with a screwdriver? Do they have the right tools for the job? Are they tensioning it correctly? If they're just tensioning it with, what a lot of guys say, the calibrated thumb, if Dave or I or Sean go to tension the belt with our thumb, all three of us are going to come up with a different tension rating. But we have various tools, pencil testers, what they call them, or we have sonic tension meters that's the best way to tension a belt, so you take the subjectivity out of it. These are those tools that we're talking about. The sonic tension meter obviously is the best way to go. Use our design software, put in the parameters, the size of the sprockets or the shivs, the center distance, the motor horsepower, what type of belt you're using, and that will give you a tension reading. And with that sonic tension meter, you can either use the inductive sensor, which is a way to test it in newtons. So you put a magnet on the belt, tape it on there, You strum it like a guitar string and it'll tell you how tight the belt is. If it's a real noisy environment, if it's not that noisy, you're on top of a building or something like that, you can use the Hertz method, which is also available with this sonic tension meter. We have the pencil testers. Those are the two silver looking things in the middle, and your shiv gauges here. And then the case to the right at the bottom, that's the easy align tool that has a laser in it. The difference between ours and like a belt hog is we have the laser in that top section in the bottom there, and then it bounces back onto the bottom piece that has a mirror so that you can make sure that you have basically parallel alignment. Failure analysis, we'll talk about different failures that might happen. So we have these charts. I don't know if you guys have those. If you don't have any, Sean, let me know. I can get you some of those. You should have had some from before. But this will list all the different ways that a belt can break so that if they have it, a belt failure, they can look at one of these, in the V-belt section, 18 possibilities. Take a look at it and see what was happening. And then down here, you can read what the failure is and what the corrective action would be for that. Same thing on the left with the synchronous. You just don't have as many variables, various ways to break that. And it's good on the left, a little about the middle, you can see where that little mirror is on our easy alignment tool. It bounces back to those lines to make sure that everything is aligned properly.
So Jerome, just out of curiosity, is there a typical failure reason that you see in the world of belts, or
the vast majority, it's like 57% of the time we see failures from belts is lack of tension. And again, that's because somebody's using their calibrated thumb. That's a vast majority of, we have belts sent to us every day. The engineers take a look at them and they can just pick it up and go lack of tension, lack of tension. The vast majority of time, even those that have tension issues, it's from the lack of tension.
If you had to pick one of two, is lack of tension or too much tension worse?
Lack of tension. Yeah, lack of tension is a major issue. Your drive's not as efficient, and the belt's nowhere near going to run anywhere to its life. Over-tensioning, depending on if it's a V-belt or a synchronous belt. If it's a V-belt, it's going to wear sooner because it's so tight and it works off of friction, so the sides are going to wear down, but it's not going to have a failure. Too much tension on a synchronous belt is just going to have the teeth wear off. Lack of tension, you'll probably jump and then rip sections of the teeth off. And like this one here on the left, probably had a lack of tension. It jumped and then it caught and then it just ripped it apart. So this one on the right is like a normal fatigue. It's just basically it's delaminating, it's coming apart. So this is one where we'd have like what we call crimp failure. That's what I was saying before. So you probably either hung this on synchronous belt on a hook and the cord was either set where it basically broke, or it was wadded up like in one of those earlier pictures with saran wrap or with a snap tie. And then when this was running and bending over and over, and then it just came apart. It looks like sort of like somebody cut it. So that's what we're talking here. Mishandling, inadequate tension again. So it could have jumped and just ripped apart, or they scrunched it all up so that it was tight and then it just bent over and over on the motor and came apart. Could be a foreign object, but that's, probably the least likely to have happened, because probably 99% of the time the belt is going to have a guard on it. We do have some up on asphalt plants and stuff like that where they don't put a guard, but the only thing that's going to go in there is if a bird or something flies in there, you're over 100 feet in the air. This is another example of improper, pinching the belt too much. You can see off to the right at the top where it says crimp, and then twist and tie where they're using like a screwdriver to pry that belt on. That's where you end up breaking the cord. So it's going to come loose from whatever type of material the belt's made out of, whether it's rubber or a plastic, and then it's just going to break apart like in the previous slide. It looked like it's straight across. Shock loads, this is when something suddenly stops the belt and it just sort of tears it apart. So it looks like it's ripped. Sort of like if you had a t-shirt and you were pulling it apart, you're going to have some that's flopping around right there. So something happened there there was like a sudden stop. So that's the failure we see on that. The shark tooth or the C-type tooth, this would be from improper tension. Again, it's probably 90% of it when its tension is from the lack of tension. So the belt tooth isn't entering the sprocket tooth properly. So it's coming in late. And so it's just riding on the edge of that tooth and it just wears down over time. If they would have kept this running, it would have just got more and more pronounced. So it would just look like somebody drew a bunch of C's, or like they say, shark tooth. And that could be like here where you didn't, in this picture you can see it's not meshed properly. The belt isn't meshed with the sprocket. So this was taken with a strobe light, so you can see it's not entering and exiting. So if you look where that arrow is to the right, you can see it's just going to wear that tooth down over time. Over-tensioning, basically you tear that, what they call the landing is in between the teeth. So it's just going to start taking the material. Again, if it's rubber or the plastic in the poly chain, it's just going to start wearing that out. Yeah, this is basically because you didn't have it aligned right. So they're going to call it synchronous, uneven tooth wearing. So as you can see from left to right, it's narrower. The width of the belt becomes more narrow. So it's basically just, it wasn't aligned right, so it's riding. More than likely, it's running up against the flange and just eating it up. It can actually ride up on top of the flange and be cutting the belt. I saw that before where the flange was actually bent because it was misaligned so much. The belt was riding on top of it and it just bent the flange over. This one, debris, again, you could have had, this could be at, say, an aggregate, and you got some rocks in there in between the belt and the sprocket. So it just sort of punched a hole in it. Could be at a lumber mill as well, a big piece of wood or something got in there. Shock load failures. Again, something happened, sudden stop, and it just rips the motor still wants to go, but whatever it's driving isn't going anywhere, so it just tears that belt apart. So this can be from misalignment. Basically, too, when you see the cracks like that on the left, that's going to be from excessive heat. And so excessive heat's going to come again from misalignment. You're going to have chunks come out of it. Basically, it's cooking it. And then the one on the right's where a piece came out of it, probably because it got too hot and it just burned up and broke away. Related, again, this is going to be, as you can see in the one on the left, it's kind of glazed. When it gets too hot, that's from the belt slipping in between the shiv, and then it gets too hot, and that's where it's going to start cracking. So the weakest point of a notch belt is from the top of the notch up to the cord. And as you can see on the picture on the left where it's real shiny, it has two cracks in it at the top of the notch, and they go all the way up to the cord. And then if you look over at the right, that's when those chunks start falling out. I don't know if you guys are familiar with how you would make a belt. Basically what happens when you make a belt is you have like a pipe. You put a couple of layers of rubber on the belt, put the cord on the belt, and then they'll put some more layers of rubber on the belt. And then they put what they call on top of it that has the inverse of these teeth in the notch version. And that sleeve there, and it'll fill with steam. And then that's how they cook the rubber and the cord to become one. And then when they take that sleeve off of steam, they'll have, it looks like a rubber trash can, like when you go to Walmart in that one aisle where there's all the black trash cans. And then they'll take that sleeve of belts over, and then they'll cut them up to the various widths that they need. And then they turn them inside out, or right side in in our case, so that the notches are on the inside. Then here's my number, email address. If you got any questions or need any help out there in the field, just give me a call, shoot me an email. We have time for me to go out there and work with you guys. We also have a district sales manager named Rob Hollister. And so both of us live not too far, probably within an hour and a half of Philadelphia. So we can go anywhere from South Carolina to Maine, wherever you have something. I'm sure we could figure out a way to get there and take care of anything for you.
Hey, Jerome. So the one part of that slide where you showed major failures, one of them was just improper design.
Yes.
I know, both power transmission specialists for Rumsey uses the gate software. I mean, is that generally that would help you design the right?
Yeah, that'll come up and tell you if there's some kind of an issue. I've messed up before and told some people, oh, you could do this or that, and then we find out, switching over to say the Predator belt that we have, which has made with Kevlar and 2 layers of nylon on the outside. Normally, if you have 6 regular 5V belts, you can switch over to say 3 of those Predator belts because they have Kevlar cord. And then once we did the drive design, you needed 5 Predators because you really needed 10 of the regular 5V belts, and that's why the drive wasn't working. I had one customer a few years ago tell me that his son was studying mechanical engineering, and for power transmission, they only had 1 paragraph in the 4 years that he went to college. And that's all they talked about for power transmission. So a lot of the engineers out there that are doing designs aren't as knowledgeable as, your PT specialist using the Gates Design Flex or the Gates Design IQ.
Okay. So that software would be the ideal place to go to really make sure that the application is correct.
Yeah, a lot of times what we do is take the existing information and run that, and then we run the proposed, what we would think would be a better solution. And there's a lot of times where you run the existing solution, you're like, oh, this is why it's not working. It's way under designed, or the shiv isn't the right size for the motor. All that kind of information will come up in the software.
Yeah, it's very important to do that. So you have a basis of that comparison. So I as well, Jerome, do that all the time.
Yeah, that way you can show them the existing state and the proposed state, and why, whatever you're proposing, obviously you're going to make sure is better than the existing state for whatever reasons. And 2, if you guys are going to look at HVAC, you can find out how much they're paying per kilowatt. And in that design software, you can put, if it's 24/7 or 5 days a week at 10 cents a kilowatt, and how much the maintenance person is getting paid, all that kind of stuff, you can put into the software and see how much you would save, say, going from a V-belt solution to a synchronous solution. We did one, I think I told you guys the other day, at Cornell, where the new drive will pay for itself in under 60 days. So under 2 months, it's like 5.5 weeks, that drive is paid for itself just from the energy savings on the electricity. So if you threw in the manpower of switching those V-belts out, say twice a year, that thing's going to pay for itself, 10 times over once you get it installed and up and running.
All right, and with that, we'll open it up to any questions anyone would maybe have. We have Jerome on the line here, so it's a good time to ask questions. I guess the only question I would have for you, Jerome, is if you're going from V belts, and upgrading that to a synchronous, are there any concerns or any issues you would have, whether or not that, say, air handler or whatever it is being controlled via an across the line start versus a VFD?
Yeah, some of the things, if you're looking at doing that, the first thing is we basically want to make sure it's 15 horsepower motor over. And the reason for that is the time the frame for that motor isn't going to be strong enough. So if you have it all locked out and tagged out, if you can grab the 2 spans of the V-belt and you can get them to touch each other, that's a no-go on a synchronous belt, because a synchronous belt isn't going to provide any slip or anything. And that's going to, what'll end up happening if you did convert it over is that lack of slip, and is going to make that frame move slightly, and eventually that frame on that motor is going to break. And it is good to have a VFD. If you're going to have the motor's going to start and run 24/7, and because you're doing, say, a science experiment at Drexel or something like that, then we usually don't worry so much about it having a soft start. But most of the time, nothing is like that where it's going to run for the next year without being turned off. But I do know in some of the colleges, some of the science buildings, they're doing experiments for the different drug manufacturers and stuff like that. So they tell us that they can't turn that air off because it's a $5 million experiment. And if they turn it off, it's just going to cause, it could destroy the whole experiment. So that's where they want to run it 24/7. In that case, you really wouldn't want to worry about the V-belt. I mean, the soft start, because it's going to start up and just run. But most of the time, you want to have a VFD on there and over 15 horsepower.
Well, with we'll let you go and have the rest of your day, everybody. I appreciate it taking the time to get on.
Thank you.
We're continuing the WebEx series, so please go to rumsey.com and sign up for other events that we have coming up.